Hi, everybody. Welcome. We are live streaming to the entire cosmos, or at least this neck of the Milky Way. So welcome online viewers. I'm Michael Shermer from the Skeptic Society and Skeptic Magazine, and we're in the home of David and Jackie Nadich, who are kind enough to let us use their fine facility here. So please thank our hosts for letting us do this. Appreciate that. David and Jackie have concerts here every so often, every few weeks or so. The musicians sit right here. Andrew and I will not be performing any musical tricks today. But so if you'd like to sign up for that, the events are on usually on weekends, so they just need an email address. So just put your email address, pass that around, and they'll let you know when the upcoming concerts are. And it's a lot of fun, which is how we discovered this. I used to live just a few doors down here. I now live in Santa Barbara. So I used to come up here, just walk up the street and watch concerts and stuff. So I thought, hey, let's do. We were looking for something new to do. So with the sort of in conversation dialogue kind of event. So that's why we invented that. So here's our latest issue of Skeptic Magazine. Be sure you get the latest copy. We have Bill Nye the Science Guy, who you probably saw in the news a lot yesterday for the Science March, the March on Science. Did anybody march for science yesterday? Very good. Yes, very good. Yeah, that was great. We were down at the Pershing Square. It was a big crowd, even though it was the hottest day of the year in this, which promises to be the hottest year on record. But, global warming's a myth, so there's no reason to worry about anything. So in a way, that's a good seg to our session today because, Bill Nye's got a new show out, which is why we did the interview with him. Bill Nye saves the world. Saving the world from what? Well, really, the kind of obvious elephant in the room, science denial. Science denialism, alternative facts, which yesterday, as I said in my speech, there are no alternative facts. There's what you call alternative facts with evidence or facts. Like alternative medicine with evidence is medicine. This is just a word for saying there's stuff we don't know about yet, and there's stuff we're pretty confident we do know a lot about, and that's what science does so well. So the obvious problem has been, and it's not new at all, the denial of evolution, for example. This is our 25th year, and we've been hammering that point since the first issue, and it's still around. And then the vaccine, autism, vaccination denial, and Holocaust denial, and GMO denial. It sort of cuts across the board, both left and right. So it's not just one problem with one administration. There's always been issues like that, which is why we have to be vigilant and march for science. And the obvious ones that we've been targeting for a long time are religious and political worldviews that we think bias people. Well, we're all biased, but bias people toward not wanting to accept evidence that counters their deepest held beliefs. So if you are a conservative who believes in free market capitalism and the free reign of industry to prosper, then you're not going to be comfortable with data in support of global warming, in case that might lead to legislation that intervenes into the marketplace with laws and regulations and so on. And so of course you don't say that. No one thinks, well, I'm a dogmatic conservative, and so they go for so-called alternative facts that supposedly counter the mainstream science. And on the religious front, of course, the old familiar one is that it's the number one predictor of people that don't accept evolution is basically if you're a fundamentalist Christian or evangelical. These are the least likely to accept the theory. So, it's not like if you go to India and they have a different kind of physics there than they do here. It's just physics is physics everywhere. Why should there be pockets of different acceptances of evolution? Well, because of religion, right? So, but what our guest today, Andrew Shtulman, has taught me, depressingly so, is that there's yet another element to science denial that goes even deeper than kind of immediate, proximate religious or political or ideological resistances to science, and that is just how our brains are wired up intuitively to think about the world. And so Andrew Shtulman is a professor of psychology and cognitive science at Occidental College, where he directs the Thinking Lab. This is my favorite title I have ever heard for a lab, the Thinking Lab. So I guess they do a lot of, thinking there. And so he holds degrees in psychology from Princeton and Harvard, and his work has been published in Scientific American, Nat Geo, The New Yorker, and he's from locally here, he's Pasadena. This is his first popular book. So I guess just to get started, before we get into the meat of what intuitive theories are, how come you decided to write this book? What was the, you're a professional academic scientist that cranks out peer-reviewed papers, but you decided to reach out to a broader audience.
Right. So my area of psychology is cognitive development, and specifically I study conceptual development, or how we acquire new concepts and form new beliefs. And that area kind of got started by Jean Piaget. He's someone you probably heard of if you took intro psych. And Piaget has had such a lasting impact on the perception of our field that if you talk to educators, people in schools, they think they're doing something scientifically informed by following Piaget's guidelines, but the field has moved far beyond Piaget, and what we've been doing in the last 30, 40 years really hasn't been that well received or acknowledged. So one of the big departures from Piaget is recognizing that development is not stage-like. That was Piaget's contribution. He thought that there are stages that children went through, and in any given stage, there are certain things you can learn and other things that are just beyond your grasp, and then you move to another stage, and new things are learnable, others still outside. But people in cognitive development realize that every domain of knowledge is its own thing, that there isn't just some general pattern of development, that to understand development, you really have to grasp the concepts themselves and understand the domain-specific trajectory. And I think everyone can intuitively grasp this by the fact that when you go to school, you have specific subjects that you take. You take, in the early grades, it might be just differentiated into like social studies, life sciences, physical sciences. And then as you move on, life sciences gets differentiated into, say, well, I guess it's still just biology. Physical sciences maybe gets differentiated into physics versus chemistry, and then these get further differentiated. So it's not like you just learn one stage of reasoning. As Piaget might suggest, that we're at level 1 reasoning, and next year we're going to engage with level 2 reasoning. All reasoning is domain specific. So we've been learning a lot about how those domains change, how knowledge within the domains change. But I feel like when I kept talking to different people, no one knew about this research. It would always come up because I would usually delve into my particular area of research, which is studying intuitive theories of evolution. And they would look at me confused and say, do you study evolution? And I say, no, I study how people think about evolution, how they understand evolution. Right, well, right. And then either the conversation ended there because they thought I was going to help them with their mental disorders, or then they'd be really curious because they had no idea that people studied domain-specific thinking. And it wasn't just me, it was everybody in our field studies domain-specific forms of thinking.
I think the average person probably has no idea what that means, domain-specific.
Oh, sorry, yeah, domain of knowledge. So rather than thinking about just like general logical competence or general critical thinking, which is more of like the Piagetian focus, that kids have a certain kind of logic and they lack other logical skills. Domain-specific means reasoning about matter, reasoning about motion, reasoning about energy, about evolution. And
there does seem to be kind of, in the long history of psychology, say going back at least a century, this obsession with putting things in stages. Mm-hmm. And maybe that itself is an intuitive theory, because we kind of think of people growing up and developing through stages. Now I'm in my adolescent stage, now I'm in my adult stage, old person's middle age stage or whatever. Right. And maybe that's a kind of an intuitive psychology of thinking about development itself.
Stages are just neat, they're clean, tidy. The intro textbook that we use at Occidental, when it covers cognitive development, it just covers Piaget stages, and you can put it into a neat little table, and they have each stage and like the characteristics that go along with the stage. And you can make some generalizations. Like at my kids' school, every year we get a pamphlet that says like, this is the stage your child is at in grade 4 or grade 5. And it's not all wrong. I mean, there's some genuine insights there, that there's some sort of coherence, and as you age, in terms of the things you're able to do and not do. But the domains of knowledge really pull apart. I mean, you can be very sophisticated in one domain and have absolutely no understanding about another domain. And so that's really the meaningful way of looking at development.
So maybe think of them as fuzzy sets, like between ages of 2 and 4, this is roughly what your child should be learning or grasping. But there's a bell curve mapped onto that block of time, so maybe half the population is slightly below that average, say at age 3, and the other half is above that between 3 and 4. And there you are, a parent of one kid going, oh no, little Johnny can't grasp algebra yet, or whatever. Right. There must be a problem, but maybe this is the problem with stage thinking. It's too categorical rather than continuum thinking.
Yeah. One problem with stages is that people progress through them at different rates. And so if you want to assign an age range to a stage, it's not really going to perfectly map on to the population. And another problem is that some of the stages that Piaget in particular posited, there are cases where given a child of a particular age can perform for a certain kind of problem, they might appear to be stage 3 rather than stage 2 in what they're actually in. For another problem, they would appear to be stage 1. For some adults, they never appear to be at the last stage, right, across all the different problems.
We know who they are.
Right. So, I think that's a problem, that it doesn't map on well to individuals. But I think the more fundamental problem is that the stages are just kind of artificial.
But it's a way of talking about things. I guess it's a heuristic to just say, get our mind around this problem. Mm-hmm. Like Kubler-Ross's death and dying stage. That's one of these memes that gets passed around. Denial, anger, bargaining, acceptance. There's some. Oh, I missed the anger stage. Oh no, I got to go back. And but there's just so many exceptions. It's almost like, why even bother to have a list? But it's a way to talk about it. Oh, you're angry. Now you're, bargaining, or you're denial or something.
Yeah.
but is it even worth it?
I guess it depends on the stages. So, for instance, in this book, in some of the domains, development is very stage-like, but it's a meaningful set of stages because it's the stages as the progression makes sense in terms of the concepts that you're learning, that you have to have this particular concept before you can then learn the next one. What ends up happening when you try to cover too much territory, when you go take a domain general perspective, is it all becomes kind of metaphorical or superficial. So you can describe a child, say, as egocentric, and you say, well, here's an example of them reasoning egocentrically, and here's another example. But if you really push it and you look at all the possible ways you can reason, egocentrism doesn't really buy you anything. That it's either just a false application of the term, it doesn't really make sense, or there's positive counterexamples where they actually seem to be very good at taking another perspective when they're not supposed to be, because they're supposed to be very egocentric.
So your hope with the book, comes out Tuesday, is that educators will read it and catch up on the literature of cognitive science. I always do wonder, when teachers in particular, but the curriculum in general, okay, so, and I'm sure I'm getting this wrong, but 4th grade is when we do geometry, and 5th grade is when or maybe it's 6th grade geometry, 7th grade is algebra 1, 8th grade is algebra 2, you get pre-calculus in 9th grade, and then, so on. Did they design this because cognitive scientists have shown that conceptual thinking in visual form like geometry is best at that stage, or is this just like an accidental byproduct of 100 years of public education, and it was pure intuition some time way back when somebody said 4th grade is the time for geometry, and that's what we're going to do?
Geometry. Usually it's not until
8th grade, whatever. It's been a while. Yeah.
I think it's probably
for some,
it's probably both. Some of it's just sort of accidental and coincidental. And on the other hand, I think if you try to teach children something that they're not ready for, not because they're sort of cognitively challenged across the board, but just that they don't have the requisite knowledge that would be the foundation, you're not going to get very far. So I don't think that the curriculum in most schools is wrong. I think there are some exceptions. I think that evolution needs to be introduced in elementary school, maybe even some more complicated physics, but I don't necessarily think that it had to have been informed by cognitive science, because I think people, just by working with children and educating children, figured out, like, we've got to introduce algebra before calculus.
Right, right. So what you're saying is that there's certain concepts, say, about inheritance, that you don't acquire it through a lifetime, that it gets passed on through genes. That's counterintuitive, so the earlier we get to them, the better. Not get to them, that's probably not a good way to say it, but
Right.
but how early could a child understand, say, the idea of genetic inheritance?
Right. Well, children have their own understanding of inheritance that's kind of proto-genetic. So inheritance is one of the chapters in that book where the structure of the book is I go through intuitive theories in each domain. An intuitive theory is an explanation for the phenomena in a domain, the things that you want to explain in the domain, and that you come up with on your own as a child, pretty much. And so within the case of inheritance, children understand inheritance in terms of essences. They think that what makes an animal is that it has the essence of that animal. So, a tiger isn't a tiger just because it has stripes and it has sharp teeth and it eats meat. They think about tigers a little bit more sophisticated, that it's a tiger because it had tiger parents and it's going to have tiger babies, and it might not have sharp teeth when it's born, but it will acquire sharp teeth because it has the essence of a tiger.
But that's true.
Yeah, no, right. Yeah, so that's actually a case where the grain, there's a, right, the intuitive theory, well, none of the intuitive theories are totally wrong, right? They all have to map onto reality enough to be useful.
Right.
So it's just that kind of reasoning only gets you so far.
Right.
Because there's lots of cases where essentialism just isn't particularly appropriate when thinking about biological kinds. So one great example is people are very quick to map on this essentialist reasoning about species to reasoning about social categories. And we like to treat different races, different ethnicities, even different socioeconomic classes as essential in their
A fixed
nature.
kind.
Yeah. And that you're inherited with a predisposition to have a certain set of behaviors and act a certain way.
Right.
Yeah.
So the brain is designed to find categories, to make categories, because often that works pretty well.
Mm-hmm.
The blueberries are good, the brown mushrooms not good, whatever.
Right.
So reading your book reminded me of a nice meme that Dawkins came up with, one of many, including the concept of memes, which was what he called middle land. So middle land is that sort of land in between really small things and big things, really slow things, really fast things. Because in the middle land of plains of Africa where we evolved, most things are, say, between the size of a grain of sand or an ant in a mountain range. And that's pretty much the scale. And then speed, animals, people walk, animals run, so you get maybe from 1 mile an hour to 100 miles an hour. That's about the range of middle land of what we're used to seeing. So things like the speed of light or an expanding cosmos, quantum physics, there's nothing in our intuitions that would help us grasp those, which is why they're very counterintuitive. So I got to thinking, that's kind of what your idea of intuitive theories is, right? It's sort of a middle land. This is what, I was just writing about this for my next book on Heavens on Earth, about the concepts of heaven, both theologically and cosmologically. So I'd say these old ideas sound insane. Who would believe these things? But if you actually go outside, in the desert where it's dark, and you just look up, and the curse of knowledge, it's hard to get rid of all the TV shows you've seen of the expanding universe. What do you see? You see a dome with a bunch of lights, and you don't feel the earth moving. It looks flat. I mean, that's our intuitions. And so I think that's in part where we're up against. You don't see any of these things. You don't see species evolve. Right. Cats don't act like dogs ever. They act like cats, and that's their essence. Right. And that's good enough for survival, I guess, and reproduction.
So the first half of the book is about intuitive theories of the physical world, and the second half, intuitive theories of the biological world. And for the physical world, it seems that those theories are very closely tied to perception, that we have certain ways of perceiving matter and motion and energy, where we form categories and we assume that there's certain properties that are true of these things. And that perception is misleading. It's perception that's useful in everyday life, and that's will get you by just fine, but it doesn't map onto reality at a deeper level. The biology stuff, on the other hand, it seems like the bigger problem there is that we lack the perception, the ability to observe things that we might want to observe. We can't look inside a body and see organs functioning or tissues functioning. We can't see evolution in action. We see the outcome of evolution, but we don't see selection happening before our eyes. We don't see germs. So that's a case where we tend to more often just default to generic, general kinds of reasoning. Like I already mentioned, essentialism is assuming that organisms have the essence that's true of their species as a whole. And that gets you so far, but if you actually want to learn about genetics, it's really genetics mostly. If you want to learn about the details of genetics, then essentialism is going to be a problem. You can kind of map genes onto essences. That's a first step, but essences have all sorts of properties that genes don't. Genes interact in complicated networks, and they have outcomes that are much more complicated than just the passing on of a pure essence from parent to child.
Right. Ernst Mayr, in his great book, The History of Biological Thought, it's a huge, massive tome, going back to Plato, and he says the whole thing has been one long battle against Platonic essentialism, that everything has a kind, and that it took, really 2,400 years to Darwin to think, okay, this is not right, and it's still sometimes hard to grasp the idea of population thinking and population shifting, because we think of individuals. And you have that great illustration of the giraffes, the two giraffes with the long necks and the one short little one that doesn't make it. And there was a funny little a meme going around the internet that I posted the other day showing, they had that exact image that you have in your book.
That's right, got it.
And the third,
it's from the meme.
From the meme. Oh, okay. So the first panel, it shows that all three of them are alive, and then the second panel, the short little giraffe is lying on the ground. Third panel, the short little giraffe is just skull and bones, is dead. And this represents Lamarckian thinking, Darwinian thinking, Malthusian thinking. Giraffes are cruel and uncaring because the little giraffe is dead. Anyway, but that is our intuition. It seems like things that you do in your own life. Right. I work out and get muscles, so my child will have muscles. Well, maybe my child has muscles because I have the genes for it, but we don't see genes. It's so counterintuitive.
Right.
It feels like it should be that way. And that's the problem.
Yeah. Well, so can I clarify that meme?
Yes,
it's actually
please.
Funnier than.
Okay. Okay.
I think it really came from like a test, like a high school test or something. It had the panel of the giraffes, and with one not getting enough food, lying down, and then eventually decomposing. And then it said, which of these principles does this illustrate? Malthus's principle, Lyell's principle, etc. And a student wrote in pencil, giraffes are cruel, heartless creatures.
Right. Right.
Right. But it so nicely captures the fact that we don't think, when we turn to evolution and try to understand intuitively, we think about it as metamorphosis. That's how it's portrayed in Pokemon. It's how it's portrayed in that line of primates turning into humans, where you've got like an ape turning into a caveman turning into human. We don't think about it in terms of selection. Because we don't view populations as a whole. We view individuals, or a collection of individuals, but not whole populations. So we don't appreciate that there's variation in the population. We don't appreciate that some of those individuals won't have enough food to eat and will be predated or will get sick. So that process of the weeding out of the unadapted forms, that's just totally invisible to us, and we just focus on the fact that things seem to be improving, or at least becoming more adaptive as a whole.
Right.
Yeah.
Well, and so this, Mayer's point was that one of the genius of Darwin was to turn this on its head and say that, that things that look designed, wings are designed to fly, eyes are designed to see, they are designed. I mean, design is the correct word for what he called adaptive function. So the design, but what is the designer? Well, natural selection is a designer. That's his argument. Natural selection is the designer. So I have to hand it to my debate opponents, the intelligent design creationists. I mean, creation was an okay word, but intelligent design is really a marketing genius because everybody, the average person knows nothing about evolution. They just yes, it looks intelligently designed until you point out things like lower backs and knees and things like that. It's like, okay, maybe that was not so intelligently designed, but that takes an extra effort. There's a whole book out now, or it's coming out. Sort of every chapter is a poorly designed part of the human body. To counter that, but that takes a book. Our intuition is like, yes, and so one of the strategies I use is to try to say, you're right, there is a designer. Wings are designed to fly. That's what natural selection does. Eyes are designed to see. That's what natural selection is the designer. Not all my evolution friends like to concede the word, because when we think of design, we think of an agent. Mm-hmm. And that's another one of those things we're up against.
Right.
That would be maybe one of your intuitive theories of human psychology, is that we tend to see agency in things.
Oh yeah, definitely. And I talk a little bit about that when I talk about evolution, that you're up against not just these essentialist intuitions that species are essentially just a whole unit evolving together, metamorphosizing together, but we also, when you see something that looks purposefully designed, you assume that there was a designer. But these lead you in different directions, right? So if you focus on the design part, that might lead you just to reject evolution altogether and endorse creationism. Whereas if you're going to accept evolution, essentialism leads you to have a theory of evolution that's not supernatural, but it's still wrong. It's kind of quasi-supernatural, because if you just assume things evolve in order to become better adapted to the environment, but you don't know how it happens, you just assume that it does. There's some kind of internal endogenous mechanism in an organism that allows it, either the organism itself to become better adapted in its lifetime, or make sure that its offspring it's going to be better adapted. But there is no such mechanism. Maybe there would have been, but it turns out that's not what was driving evolution after all.
So do you ever encounter creationists? Any of your students say anything like that, or encounter them out? I mean, what should we say? I mean, we can't say, oh, you're locked into Platonic essentialism, or you're an idiot, or even worse. So strategically, how should we approach this problem of the average person's intuitions are wrong, and science says it's a different way.
Right.
Of course, what all of us want to know is, well, what should I say? I'm at the dinner party or whatever, and it's like,
yeah. Well, right. So if you're up against a creationist, I think that's a much harder challenge than if you're up against someone who thinks they understand evolution but doesn't.
Right.
Because they presumably are more open to recognizing that they've got the mechanism wrong. With creationism, there's all sorts of additional commitments, like social commitments and ethical commitments.
Right. Yeah.
And I mean, the point that I make is that creationism is an intuitive stance, but it goes beyond just the intuition. Like, it gets fleshed out in all these culturally constructed ways. Religions have their own particular ways of thinking about creation. For the intuitive theories that are more natural in flavor, those ones you kind of create on your own, and no one's instructing you. No one's telling you specifically, like, evolution works like metamorphosis. You kind of just intuit that from how you understand what a species is, and how you understand what people are saying about evolution, and your ability to try to interpret evidence that you have for evolution if you go to a museum or you read a textbook or so forth. So the intuitive theories are probably not as well developed. They're coherent in that if you go from one person to the next, and you ask them to reason about evolution in various ways, they'll give you similar kinds of responses that are different from how evolution actually works by natural selection. But they're not articulated to the same extent that a creationist theory is, and it's not practiced. It's something that, it's a coherent set of beliefs, but it's not one that there's a community that has adopted.
Oh, right.
At least not now. Like in
Right.
the past, there was communities that did, which are early scientists. So it's another point that I make in different chapters, that when scientists first put their mind to explaining these various phenomena, they basically worked with their intuitions. They had the intuitive theories that children form today and many adults today hold, and then they put those theories to the test. But being scientists, they recognized that there were flaws, that when they did the experiments and they didn't come back the way that they should have, given their intuitions, then they were open to coming up with new theories. And so eventually the intuitive theories got replaced by scientific theories, which got replaced by better scientific theories.
You have that great illustration of the cannonball shooting up into the air. So the cannon is like this, and the old impetus theory, Aristotelian impetus theory, is the cannonball goes as long as the impetus keeps pushing it, and then it runs out, and then it goes straight down, almost like cartoon physics. So it realizes, and then boom. But it seems like they maybe should have figured that out earlier, because if you just shoot a cannonball, they're slow enough you can see them. It's a parabolic arch.
Yeah.
Or even Aristotle's, the heavier object will fall faster. You'd think they would just go, okay, let's just test this.
Right.
Obviously not the case.
Right. Yeah, I think that's one of the most fascinating things about intuitive theories, is that they're so impervious to counter evidence. Cannonballs have always traced parabolic paths. Any projectile traces a parabolic path. But you can just be oblivious to that. You can watch it over and over again and not recognize that your way of explaining motion is positively contradicted by the way things actually move. So in the chapter on motion, I talk about how a lot of physics educators think that the way to get kids to understand that their intuitive views of motion are wrong is to do hands-on experiments. And hands-on experiments could be effective if they're done properly, if there's enough framing there, so it's clear what hypotheses the experiments are meant to test, and the kids have to record their data. But more often than not, you just give them materials and assume they're going to discover the principles on their own, and they never do. Every time you just, so the typical experiment would be one where you're given materials and the teacher says, figure out which variables matter. So for instance, if the task is rolling balls down a ramp, and you can manipulate ramp incline, the weight of the balls, the texture of the ramp, and you say, okay, figure out which variables make a difference in terms of the speed of the balls hitting the bottom after they're released. They will come in thinking that weight matters, when in fact it doesn't, because if you release them at the same time, they'll hit the bottom at the same time, and they'll never learn otherwise. Even if they do the right trials where they don't manipulate anything else, just the weight of the balls, and they see they actually hit the bottom at the same time, they think that either they didn't release them at the same time, or that it just doesn't actually make a difference.
Somebody did this decades ago where they had like a cannonball and like a golf ball or something like that, and let's test it. And they did not land at the same time. And the problem was the cannonball was so heavy, they were holding it tighter, and it took just a fraction of a longer second to release it, so that the lighter object actually hit first. So the science has to be done very carefully.
Right. Yeah, I mean, you could also manufacture the wrong observations.
Yeah, so you're not asking the question correctly, or your experiment is not set up properly to test what you think you're testing.
Right. But there's another great set of experiments that come out of the psychophysics literature, which is, they weren't even meant to tap into intuitive theories per se. That wasn't the point. It was just, how do people perceive motion and remember motion? And so in one case, they show people a little ball that's shot through a curved tube. And when you shoot something through a curved tube, it will exit the tube in a straight line. It doesn't continue to curve, but a lot of people think explicitly that it will continue to curve because they think it's acquired a force, and the force is a curved force, a bending force, right? Yeah. So in these experiments, they show people a ball shot through a curved tube, and it travels off in a straight path. And then you wait a few seconds and you say, okay, now draw the path of the 500 milliseconds after it left the tube. And invariably, they think it went off in a curve after just watching it go off in a straight path.
Okay, that's depressing because it implies that even if we show people, the climate data or the evolution data or whatever, they're just going to go, they're not even going to see it.
Right.
I mean, it's not that they're dumb or uneducated or illogical. They're not even seeing what you're showing them.
Yeah, that's probably true. I mean, there might
No.
I mean, there might be something different about like static data, a data set, or than just an observation that's fleeting. But yeah, you can. I think that if you don't point out what's important in the data set, they're not going to see it on their own.
Right.
And even if you do point it out, there's going to be all these other cognitive mechanisms that come into play to help you preserve your theories.
A friend of mine the other day was complaining about there's some new science museum, I forget if I think it's in Santa Barbara, and that they have no labels on anything. And he was complaining, the kids just do stuff. They play stuff in knobs and this, and he said, they're not learning anything.
They're not.
No, yeah, I think I agree with him. I don't want to just sound like an old guy, the kids these days, But really, if you don't even say what it is you're testing, even if you don't tell them what the answer is.
Right. I mean, it's not as if that kind of interaction isn't helpful or useful. It just has to be contextualized, right? You have to go into it with guidance. So there's placards at museums that tell you, this is what you should do to interact appropriately with this exhibit, and this is what you will likely observe, and this is the reason,
right.
Here's the interpretation. But most people don't read the placard. They just go and play with
I think that was the reasoning behind this new museum is if you watch kids going through a museum, you have a block of type, they're not reading it. They just, look, boom, boom, up to the next one.
Right.
So I guess the idea was at least if they do something with their hands, they're engaging science somehow.
Yeah.
And they're not really.
Yeah.
They're really engaging their intuitive theories, and they're not even going to see what's going on probably.
Right. I mean, there's another, I don't talk about this in the book, but there's another dimension of science, which is understanding science as a method of inquiry. So in that book, it's about the content of science, the theories themselves within each domain. But there's this whole other literature looking at how people understand science as a method of inquiry. And for kids, they think that the point of science experiments is just to show that they're right, that they will do something over and over again that's consistent with their predictions because they think they just want to demonstrate that they knew it all along.
Well, some
older
of them might
kids
do
and
that.
adults, though, changed their views, and they understand that it is about testing whether you're right, not just demonstrating that you are right. But even in those cases, it's hard to recognize when you've been shown wrong, that the test has come back negative. Yeah.
Right. So again, my next book, I have a section on children's conception of death and the afterlife and heaven and all that. So I was glad to see that I got the right literature after reading your chapter. But it was interesting, again, that Slaughter, I think was her name, that did that. So from 0 to 2, this is children's conception of death, and 2 to 4 and so on. But again, it's a fuzzy category. Mm-hmm. But in a way, so I begin my book by talking about the paradox of death, that to experience something, you actually have to be alive. So you cannot experience death. I mean, if you say to somebody, close your eyes and imagine yourself dead, what do you see? Oh, there's my body in the cat. Oh, my friends, and hopefully they're crying, and hopefully they feel really bad. No, you wouldn't see anything. It's like, imagine there's no universe. You can't, because to be alive is to experience something, and you can't experience nothing. Even the concept of nothing, we had Lawrence Krauss here last time talking about nothing. You can't even really conceive of it, true nothing, because the observer is now part of the world experiencing the nothing, so that's a something. And a no thing is a thing that's not there, so there has to be a thing that's not there. Anyway, and so in this particular one, I think all of us never really grow out of the sense that we're immortal, because you cannot conceive of not being alive, really. And so this might be the basis of much religious beliefs about the afterlife. There just has to be, in that sense. That's one of those ones where maybe these intuitive theories that hopefully people grow out of, but maybe not, it continues.
Right. Yeah, so the intuitive theory that's important for understanding death is to understand death, you have to understand it's the opposite of life, and little kids think about life just in terms of motion. If something moves on its own in a goal-directed kind of way, then they think it's alive. So they deny that plants are alive because they don't seem to move, and they think that some other things that do move but aren't alive are alive, like the sun and the clouds and fire. They'll claim that those things are alive. So they have to, in order to understand what makes something alive, you have to understand that a little bit about metabolic processing, that living things have internal parts and they take in something from the environment that they can use as energy. And in order to make that connection, you have to know that there's internal parts. So teaching kids about organs and tissues and their interrelated functions, that's really helpful for constructing a scientific framework. The body is really the first scientific framework for understanding life. And then once you've got the body and life as like the product of the body, then death can make sense because it's the breakdown of the body and thus the cessation of life. Right, but it's...
So they need that knowledge.
I mean, you can understand death. So what little kids understand, how they understand death before they understand the body and life from a biological point of view is as sleep or travel, because these are the two states that they can observe that seem most similar to death, and it's also the way we talk about death, right? We talk about people who have died as departed, the dearly departed.
So they're traveling somewhere.
You're right. Right. They've left this world. They've moved on.
Right.
I heard somebody describe a colleague at another university as having moved on. But I didn't want to ask if that meant they left the university or they had died because they were older. So, but anyway. And then we also talk about death as a kind of sleep, like rest in peace, at rest, and so forth. And so because kids don't have any biological way of interpreting death, they think it's either sleep or travel. And it's incredibly frightening because they don't know if they're going to fall into that death-like state when they fall asleep. Or it's also emotionally scarring when someone told you, like, grandma has moved on. What does that mean? She doesn't want to be with us anymore? Why is she traveled away? Yeah.
Right. And you talk about that experiment again. I think it was Slaughter and her colleagues that did that, where they introduced to young children the functions of the organs by putting on this vest that had a little strap of, like, velcroed on, I guess, organs, and you take it off and read about what it does or whatever. Maybe that's a good museum thing that they could do with kids, something like that. But that the follow-up was that they had a better conception of death after understanding the function of the organs.
Right.
But more importantly, even, I guess, a more emotionally mature concept of death. Less anxiety about death or fear of death, but more sort of realization this is part of living.
Right.
At the end.
Yeah, that's the kind of the counterintuitive takeaway from those studies, was that teaching kids a biological, scientific concept of death leads to less anxiety, not more anxiety. Because many people shy away from talking about death because they think it's going to just prime kids to think about it, and they never think about it on their own, but they do think about it on their own. If death occurs in their family or in their community, they want to know what happened. Yeah,
right.
An animal, exactly. So they do think about it on their own, and they explain it in ways that are terrifying. Like, prolonged sleep, prolonged travel.
So the child might wonder, well, wait, if I go to sleep tonight, that might mean I'm passing on somewhere.
Yeah.
And won't come back. Yeah, I like this passage you wrote. In fact, I quoted it in my book. I got the first round of edits back because I already turned the manuscript in, but I can still add some stuff before they send you the galleys and say, don't add anything more. Like, oh no, I found another study. So I managed to get this in because it's so beautifully written. Children know of death long before they understand it, initially conceiving of death as an altered form of life. How frightening it must be for them to think that we bury people who still need food and water, or that we cremate people who still think and feel pain. How sad it must be for children to think that a loved one has left home but is still living on somewhere else. Understanding death in biological terms quells those unfounded fears. Fears never well, you made reference to this gorilla, but other apes don't have that we do. I just think that, so on a deeper level, teaching the realities of the world, which is what science does, is good. It's good for us, ultimately.
Mm-hmm. Yeah, definitely. I mean, there's every scientific theory that I cover in there. I can't think of any reason why you wouldn't want to learn it.
Well, except for, say, somebody, the religious person says to me, well, okay, so there you are in the hospital bed, the hospice with your loved one there, and they think they're going on to a better place. You're not going to launch in there and go, hey, dude, there's no heaven. Didn't you read Dawkins? Right. I mean, come on. You're not going to say that, of course, but what do you say? You don't want to play along and go, like Ricky Gervais and the History of Lying, or whatever the name of that movie was, where everyone gets a big mansion. A mansion? Oh yes, a mansion. And then he goes on and on about this, and she dies happy. And the point of his movie is like, isn't it okay to lie sometime? Well, hopefully not.
Right.
But that's a pretty big one to like slam somebody with reality. No, this is.
Right. I mean, I guess they
Sorry to put you on the spot, but what would you say?
I mean, if you really think deeply about the afterlife, there's all sorts of problems there too, right? Like, do you want to continue living forever? Like, wouldn't you get bored? And isn't the afterlife filled with like people who've lived forever? Do you want to be with all of those people again? And most of them were probably really awful people if they died in the Middle Ages.
Right. Julia Sweeney has a funny bit about that, about the Mormons that come to her house and telling her about all the things like, and in heaven, if you were blind, you get to see again, and if you were deaf, you get to hear again. And she had uterine cancer, so she had her uterus removed. She goes, do I get my uterus back? And they said, yes. She goes, I don't want it back. Yeah. Or that you get to spend eternity with your family. She goes, oh, that would not be good for me. So right. Yes, I mean, of course, but. Yeah.
And lots of people think the afterlife is not going to be a happy one.
Right.
They're terrified because of their sins, right? They think they're going to be punished.
Right.
Yeah.
Well, there's additional problems too. That how does it happen? If God just makes a copy of you, what is the resurrection? You're resurrected in heaven as what? Your soul, or some religions think it's your actual physical body. Right. But then if your body is actually in the grave, then what's up there? Well, it's a copy. Okay, well, this is what people like Ray Kurzweil and these they want to make a copy, or the cryonics people, the extropians. We'll make a copy of you or your mind, your connectome, it's called, the equivalent of your genome. Every single synaptic connection, so every memory is now in the computer, like Johnny Depp in Transcendence. There it is in the computer. You turn it on, you're in there. But wait a minute, if you actually did this while you were still alive, we made the connectome copy and put it in another human, you would not be, you're through the eyes perspective of the world, what's called the point of view self versus the memory self. You would not suddenly be in your twin copy looking through his eyes. You'd still be looking through your eyes. So it's just a copy of you. So how is a copy in heaven somehow different? It's just a copy, as if you were actually still alive here. Which one is you?
Well, you're not engaging with like the spiritual nature of the transformation.
That's true.
There is something metaphysical that's probably happening.
Well, this is what
of course destroys that logic.
Well, the soul is supposed to be that, but what is that? Well, I know you don't know, but I mean, this is it's an interesting problem for. Okay, so religious people really have the same problem that scientists like Ray Kurzweil, when we're going to copy and we're going to live forever. It's the same problem as what? So if it's the soul, what is that? It has to be all your memories, your thoughts, all your personality, everything. So what's the substrate? Even if you manage to do it and put it in a machine, it's just a copy of you. Now I'm not sure about this. I hope I'm wrong. But if you made a copy and you turn on the computer, you're not looking through the little camera or the screen. You're still there.
Yeah.
In other words, a copy of your complete connectome is not going to carry with it over to the new machine the point of view. Like you go to sleep tonight, you wake up tomorrow, there's the continuity. It's still, your point of view is still there. You get surgery, come out of anesthesia, you're groggy for a little while, but the memories come back and you're still looking through your eyes. There's the world. This is my perspective. I don't see how that could happen with a copy put in a computer or in heaven. Anyway, that's just a little. Sorry to bum you out or anything, but
there's something relevant that I talk about in the book, which is that children's ability to construct a biological theory of life and death is actually delayed by religious testimony. That children are positively confused by that testimony because people talk about the dead as still existing, and not even metaphorically. Like adult recognizes that move on is a metaphor, but in terms of like their spirit living on in heaven, what that is when you talk to children in those terms, they tend to default to less biological views of life and death, right. So if you're concerned about quelling a child's anxieties about death, just giving them a big dose of religion, that's probably not all that helpful, because they're not going to develop the biological framework for understanding death as a cessation of bodily function. So you're adding confusion. The intuitive theory is not helpful. The religious talk just makes it even more complicated.
Right.
Yeah.
So you're a research scientist. You go out in the field and you talk to people. You give them surveys. You test them on things to see how they think about these things. Little kids, I mean, or your graduate students go do this or whatever. So just walk us through like a typical experiment that you've published in a paper. Like you go to a park and there's some parents with their kids. May I do this with your child? And you show them something or whatever. How do you determine what they're thinking?
So let me walk you through a task. It's not in the book because it's later a study, but we were trying to teach children about evolution. Because one question that's kind of raised in the book, and it's been raised in the field, is, are children able to learn about evolution? Or is evolution one of these things that's so conceptually complex that you really do need to wait until high school, which is when it's first introduced to most students in this country? So what we did is we do most of our testing at parks in California because it's sunny and warm all year round, so they're always there. Like in Boston, where I got my PhD, we would bring them into the lab, but that's much more time consuming. So we'll go to a park and we'll have our materials with us. So for this particular study, we needed a pre-test and a post-test to see whether our little intervention, our instruction about evolution worked. So our pre-test and our post-test was just asking them why they think, or how animals got the traits that they have. So we would say, show them a picture of a pelican with a large beak, and we ask them, why do pelicans have large beaks? And most of them knew. If not, we would tell them it's for catching fish. And then we would say, a long time ago, the ancestors of pelicans didn't have large beaks. How do you think large beak pelicans came from small beak ones? And at pretest, they didn't know. They would typically just say, well, they needed it. And that's how adults tend to reason about evolution. You need it, so you develop it. And then we had an instructional period where we walked them through the logic of natural selection for two different adaptations, how is it that these bunnies that live in the Arctic have white fur if they came from bunnies that had brown fur? And we walked them through a case of natural selection, and then another case, and then we drew some analogies between the two cases. And then at post-test, we asked them the same questions. Here's a katydid. It's a little bug that has green leaf-like wings. Why do you think their wings look like that? And how did they develop those wings if their ancestors didn't have them? And they would give us a response, and then we collect all those responses, and we go back to the lab and we code them for the things. In this case, what we were looking for is some articulation of variation in the population, and differential survival, differential reproduction, and so forth. And we found that in that particular study worked, that kids, as long as they were 7 and older, they actually learned something from our 10-minute tutorial.
7, so that's second grade.
Second grade,
so that's
yeah.
Okay. So
the younger kids didn't really learn, but the older ones did.
And you just walk them through, like, there's a population of bunnies. Some have slightly darker brown fur, medium brown fur, lighter brown fur, and then the colder the climate, the whiter it is. So these over here are more likely to survive because they're camouflaged, and then they have a population with even whiter fur. And
it was in the form of a book. We illustrated each of the steps for them.
And they can get that, more or less. Yes.
Yeah, they did.
Well, that's good. That's encouraging.
In general, what we do is we ask them questions where we predict that, given the materials in front of them, they're going to make a certain kind of response, and we code those responses back in the lab and analyze them statistically. The creativity comes in with the particular materials you present them and the particular tasks you present them.
So could you translate your intervention tool into an actual teaching module, like an app on a phone for kids, because they like phones and apps, and or for teachers, like an instructional little booklet, like here is what you should teach in lesson 17 in second grade when you're talking about life.
Right. Yeah, well,
you should do this.
I could. I mean, there's other people who are doing this too. So there's a community effort now. And in fact, one of my colleagues, Deb Kellerman at Boston University, is publishing a book that's kind of similar to the book that we created. So there'll be something available
But
soon.
I mean, I wonder if one of these teaching companies that produces instructional materials, you should get in on that. Yeah. There's a marketable product there, maybe.
Right.
But important for the future of science education in America.
Right.
Let's talk about climate for a second. I mean, it's the same problem. You don't see the climate change. I'm thinking of Senator James Inhofe's famous snowball in the Senate. Look, there's a snowball. Global warming. I mean, it's just so lame. But I guess intuitively, you don't see climate change happening over centuries. Right. Which is why it requires ice core data. Look, 400,000 years ago, it was parts per million this, now it's this, and graph it, and tree ring data, whatever. I mean, that's hard. First of all, it's hard data to get, and it takes a long time. It's a big, massive research. The average person just says, well, it was sunny, it was cold the other day, why should I worry?
Right. Well, so I think maybe one of the values of the stuff that I talk about in this book is that if you want to change people's beliefs to be more in line with science, you can't just present them data, right? Because the data, to interpret the data properly, it assumes that you've got the underlying concepts, that you understand the issue from a scientific point of view. And for most people, that's just not going to be the case, that they have an intuitive way of thinking about climate and climate change that doesn't map onto the scientific way. So when you show them the data, they don't understand why it's supposed to convince them. They can't interpret it. It's very easy to dismiss. And so I think a big challenge is figuring out how to engage the public at that conceptual level. It's easier task that's achievable with students who are a captured audience. You've got them for a year and you can teach them something, and you can be very explicit about getting them to elicit their intuitive beliefs and show them how those intuitive beliefs are different from the way scientists think. In fact, they're different from just the way the world works, right? Two balls dropped at the same time will hit the ground at the same time, regardless of their weight. It's not just scientists who say that, that's reality. So you have more flexibility in working with this captured audience. I'm not really sure how to achieve conceptual development or change with adults who've already are out of school, especially ones who are motivated to reject the science.
Right.
That's a really challenging mission.
Some climate activists try making a distinction between weather and climate. When you say, oh, well, it was cold the other day, you say, no, that's the weather. Right. We're talking about climate. I don't know if that's a good enough concept to shift them over, day to day versus long term, really what we're talking about. And again, I think it's that problem of categorical thinking versus continuous thinking. Mm-hmm. We're talking about a long-term, just the knife, the saw curved blade goes up and down, but it's bending, it's tilted upward slightly. Mm-hmm. And I try these different things. That doesn't often work because of the other obstacles, but conceptually.
No, I think that's right. That if you can develop some small one-liners where you can really point out that's not right for this reason, you're talking about weather, not climate. Yeah. And in the moment, I don't think you're going to change any opinions, but you might instill some doubt. For people who are kind of on the fence anyway, they might be more attentive to that difference in the future as they encounter people talking about weather versus climate.
What are some of the other intuitive, you mentioned in your subsequent research on sort of folk psychology, folk mathematics, the way we kind of think about other people, or numbers.
Right. So in that book, I cover 12 intuitive theories, but there's many more that are not within biology. Well, actually, some more in biology and physics I don't cover, but many more in other domains of knowledge, like psychology, the way that we understand and predict other people's behavior. We don't do that just in terms of a fragmented set of heuristics. We have intuitive theories for thinking about why people do the things they do. Those, I think, are generally pretty accurate. And they need fine-tuning over the course of development. But we're never, well, no, there is one major change, and that's the change that happens between ages 3 and 4, which is developing an understanding of beliefs. So a 3-year-old understands other people's behaviors in terms of their goals, but not necessarily how they've represented the world. And so they don't understand that a person might do something on the basis of a false belief. The best way to illustrate this is just with the task, the Sally Ann task. It's the task that people use to measure false belief understanding. So you show children 2 puppets, one Sally, one Ann, and Sally has a marble and a basket, and Ann has a box. And Sally takes her marble and she puts it in her basket, and then she leaves. And then Ann goes over to Sally's basket, takes the marble out, and puts it in her Ann's box. And then Sally comes back, Ann leaves, and Sally comes back in the room looking for her marble. Where is she going to look? So Sally has a false belief that the marble is in the basket where she left it. So adults say she's going to look in the basket. But little kids, 3-year-olds, say she's going to look where the marble actually is in the box. So they understand that they predict Sally's behavior in terms of her goals. She wants her marble. And in terms of their own beliefs, the child's own beliefs, but not in terms of Sally's beliefs. So that's one major change that has to happen. But beyond that, it seems
roughly
a lot.
what age is that?
About age 4 is when kids can pass that task.
Right. The other one I saw was the box of crayons versus candles. I think Alison Gopnik did that research back in the 80s. Mm-hmm. And yeah, I think it was about that same age. And that applies to how we think about other people too, but their intentions, right? And also the sort of theory of mind that, I know that you're thinking that I'm going to be, and I'm thinking that that I am going to, that takes a little more, like a Jane Austen novel,
right.
With all these, and she was thinking that he really loved this, and
right.
and that's probably even further developmental line.
Right. Yeah. So there's more development, but it's sort of fleshing out the theory or sort of applying it at a second level, but there's not a new logic to understanding how people behave in the way that there is a new logic to understanding what matter is or what motion is in all the cases in the book. Another really great example of a shift in another domain that's not covered in the book is understanding rational numbers, fractions and decimals. Kids learn how to count when they're about 3.5, and so as soon as you know how to count, you basically have an understanding of integers. Well, natural numbers. They don't know about negative numbers. But anyways, fractions and decimals are fundamentally different from natural numbers. You can think about them as the division of 2 natural numbers, and then that's how you would get a fraction. A fraction is a nice crystallized division, 1 divided by 3, or 6 divided by 5, or whatever. And so when kids are introduced to those numbers, they think their first interpretation is they've learned a new natural number that they just hadn't been told about before. So like the first fractions they're introduced to are like 1/2, 1/4, 1/3, and so they'll say, how do you count? Well, I used to think it was 1, 2, 3, 4, but now I know it's 1/4, 1/3, 1/2, 1, 2, 3, 4. So they think of them as new count just words, basically.
Smaller numbers.
But they don't understand their magnitude. Like they can't place them on a number line. They don't understand that there's sort of an infinite number of fractions between any 2 numbers, and there's all sorts of complicated issues where you have to develop a new model of number to understand fractions and decimals.
Could you teach that with just slicing up a pie? Just there it is, 1/2, 1/4, 1/8, 1/16.
That's what people do all the time, and it's not very effective.
Doesn't work.
No.
Darn. All right.
No, the problem is that it helps you understand fractional notation. So if you divide a pie into 4ths, then it's clear that the denominator refers to the number of pieces and the numerator refers to how many parts you have. But that's about as far as it goes. That you don't understand it in terms of division per se, and you don't think there's like an infinite number of fractions that are possible. A much better way of teaching kids about rational number is with continuous quantities and get them to associate fractions with like divisions of water in a beaker, or like the way you could break up time, or you could break up distance. When you work with discrete pieces, like pieces of a pie, it just reinforces this notion that we're talking about a number, a count word, like 1, 2, 3. Here's 1/2.
Right. But the teaching people to think on a continuum basis rather than a categorical basis, which is hard because it's counterintuitive that way. But this would be so important if we could do this. It's like, we define poverty in a certain way. The UN defines it as making less than $2.50 a day for regular poverty, and less than $1.25 a day for extreme poverty, as if you made $2.75, you're no longer poor. Well, yeah, you're still pretty poor, but how about if it was $3? Now you're just, we want to put it in a category of some kind, when really it's irrelevant, because what we really want to know is exactly how much do you make a year, regardless of what you call it. But when we want to raise money for charities or pass laws that help people or whatever, you got to call it something, I guess. And that's, we're sort of bumping up against, we got to use categories and words because we have to talk. Versus the way we think, which kind of maps onto that, but it'd be better if we didn't think that way. Same thing, population thinking for evolution versus, the typology or the essentialism.
Yeah, I think there's lots of cases where that's the big sticking point, is like continuous quantities that we have to describe in discrete terms. I think there's other cases, though, that don't really fit that dichotomy all too well. Like how people think about heat.
Oh, right.
So
they don't have a category for that.
Yeah, right. The average person thinks about heat as a substance that flows in and out of objects and can be trapped in an object or contained, as opposed to thinking about it as kinetic energy at the molecular level. So I don't think it's a problem of continuous versus discrete. It's just that you've sort of carved up the world the wrong way.
Right. I was thinking about that, reading that section about firewalking. When people see firewalking, they think they also almost impute agency to their feet to push off the heat by thinking really positive thoughts. Like Tony Robbins, gives this whole thing about, cool moss, cool moss. We're going to chant cool, and that's going to somehow translate into the bottom of your feet not getting burnt. And then you give the explanation, which is super simple, is that it's not the temperature, it's the conductivity of the heat from one substance to another. And dead wood burned is a poor conductor of heat into your dead flesh on the bottom of your feet, and the better calluses you have, the better, by the way, because it does get hot. And if you don't dawdle and take selfies standing there on the, you're not likely to get burnt. And if you walked across a bed of hot frying pans or whatever, you'd get burnt instantly because the conductivity of the heat is so fast. And then I use the analogy: put the cake in the oven, 450 degrees. Put your hand in the oven, the air is 450 degrees. You don't get burnt. You touch the cake, it's 450 degrees. You don't get burnt. Touch the cake pan, you're burnt instantly. Everybody gets that pretty quickly. But so you make the shift from temperature to heat conductivity, and then they get it.
Right.
And still, people are still doing firewalks, despite the fact we keep telling them that's not. I mean, just last year, Tony Robbins had like 5,000 people walked across and a bunch of them got burned and so on. Because it does happen. Again, they screw up and stand, or they don't. If you make the bed too long, then the temperature builds up as you go, or they're tender feet. And I don't know how I got off on this, but but it's an interesting problem again, how you counter intuitive ideas. And I was thinking about this with folk economics too, that we evolved in an environment where there was no wealth. I mean, there's no income inequality because there was no income. Pretty much everyone was equal. This is why hunter-gatherer communities are egalitarian, because no one has much of anything. So the modern world of people having enormous amounts of wealth, and then you can see the differences, feels really wrong and just counterintuitive to what we know. Right. Again, the actions of the invisible hand. It's invisible. How would you even see it? And so economists pound away constantly about this, and they have the same problem, teaching people this is how an economist thinks about the world, which is totally counterintuitive.
Yeah, most treatments of intuition in psychology are about economic kinds of intuitions. Like the classic work by Dan Kahneman and Amos Tversky is about heuristics, but it's really heuristics that are applied to like understanding value and probability. I mean, they're kind of general, but there's that that work has really been embraced by people working at the intersection of economics and psychology. So I think that's an area where the fact that our intuitions are problematic has really been embraced, and change is starting to happen as a result of that recognition. But I don't think people in general know about the intuitions that underlie our understanding of like natural phenomena.
Yeah. There's a good book out about sort of a biographical book of Tversky and Kahneman. What's it called, the title? The Undoing Project, yes. So, it's Michael Lewis. He's a great writer. He did Moneyball. So he really shows how they stumbled into this independently and then together, really trying to counter a lot of these intuitive ideas that people have about the world. Well, I'm going to be mindful of our time, but just finish up with one last kind of general epistemological question about problem I wrote one of my columns about with Donald Hoffman's theory of interface theory of perception, IPT, interface theory of perception. Now, I know you're not familiar with this, so I won't put you on the spot about that, but reading your book, I thought it was a good counter to his argument. His argument is that natural selection did not select for our perceptual apparatus and brains to create an accurate model of the world, of reality. Really, the whole point of evolution is just to pass on your genes. So the only thing you care about is eating, reproducing, the 4 F's, right? Fight, flight, food, and reproduction. And so, that's the little joke. And so his metaphor is the GUI, the graphical user interface. So you have your laptop screen, and you have like a little trash can there that you drag the files into the trash can. But if you open up the back of your laptop, there's no trash can in there. There's no files, just like if you open up the back of your skull and the visual cortex back there, there's no apples or roses or sunsets or anything like that, of course. But basically what he's saying is that it's all like, icons. These are just icons, the snake icon, the rock icon, or whatever, and so here he kind of pushes it far enough that even Deepak Chopra loves it, which is how I heard about it, because Deepak said, you got to read this guy's paper because it completely supports my theory, which he does. He's always sending me articles, which is fine. But the question is but wait, I mean, like a dolphin's vision or map of a shark in its brain is undoubtedly completely different from mine. They have sonar. They're bouncing sound waves off the shark, okay? So whatever it looks like in its brain is surely completely different from mine, just like the famous What It's Like to Be a Bat, Thomas Nagel's famous paper, right? So the only way to know I'd have to get sonar and then bolt on some sonar receptive neurons in my cortex and so on. And pretty much the only way to really know what it's like to be a dolphin is to actually be a dolphin, in which case I'd have no idea that I'm even asking the question, because I'd just be a dolphin. So it's one of those kind of philosophical, we can't answer it, right? But to me, it seems like, regardless of what it really looks like in the brain, sharks still have sharp pointy things on one end and a big tail at the other end, and it's an eating machine, and you should avoid it at all costs. Now he would say, yes, that's right, natural selection, avoidance, look for prey, avoid predators, find mates. Yes, but still, there has to be some accurate mapping onto reality. So the bat bounces something off here, and no doubt this corner looks different than the way I see it or feel it, but there's still a hard object here. There's still really a corner, really there, regardless of what your brain describes it. So it seems to me that your argument about intuitive theories, that they're kind of right for a good reason. There really are predators. They're things you should avoid. Mm-hmm. They're corners you should not bump and things like this, right?
Mm-hmm. So the strong claim of interface theory is that
we can't ever know reality. Yeah, it's beyond our reach. It's a little bit like the Mysterians argument. The Mysterians say there's mysteries that we can never know. We just don't have the conceptual apparatus.
But is it that we can never know reality and that's it? Or that reality, it doesn't correspond to reality? Is it like there might be correspondences, but we don't know? We can't ascertain whether or not there's correspondences?
Yes, correct. Yes. Oh. Yeah.
Okay.
I mean, I met him. He's a super. I mean, he's a super good guy, and he admitted he's kind of pushing the envelope because he now has a book agent, and they're like, you got to do a book about this. He's like, okay, so he's pushing the thesis. Okay, that's fine. All authors do that. But at some point, as I told him, I still got to pay my mortgage on Monday. So even if it's not real, it's on some other level, it's real. There's certain, it may be metaphorically real, but it's real enough that I got to pay attention to it.
Yeah. So I don't think the intuitive theories approach to thinking about knowledge can really weigh in on that claim one way or the other. I mean, I think the view is that the intuitive theories we construct, we do so because they are helpful with dealing with reality, whether or not but it's helpful for dealing with the kinds of problems that we would encounter as human beings, as opposed to dealing with reality at its fundamental, its deepest levels. Like in the case of heat, we don't want to be burned, right? So what matters to us is conductivity, how quickly heat will be transferred from an object to us, or vice versa, from us to something else, if we don't want to be frostbitten. So we don't ultimately care about heat. What we care about is heat transfer, right?
Right.
So, yeah, I mean, and heat conductivity is a real property of the real world, and we have developed sensory apparatus for accurately gauging conductivity, but we haven't developed we don't have an evolved apparatus for measuring heat as physicists understand heat.
Yeah, it's like the point Krauss made last time, was that it's not like Einstein overturned Newton. The Newtonian mechanics still works just fine at this particular level of the physical world, but there's this other part of the physical world that doesn't apply to, so we need a new physics, and it will always be like that.
Yeah.
So it's not that they're wrong.
Right, so the scientific view, sometimes it's totally in contradiction to the way we had been thinking about it before, but oftentimes it's a larger framework where all the incomplete parts get fleshed out. So now you understand why it is that two objects at the same temperature can feel different, have different provide different sensations of warmth to us, right? You go into a bathroom and the tiles feel cooler than the towels.
Right.
But they're at
all
the same temperature, right?
Yeah.
So we naturally think that the towels have more heat or they're better at trapping heat or something like that. But when you get the scientific framework that makes sense of heat, temperature, conductivity, then it all kind of falls into place, and you realize, what I'm actually being able to sense is conductivity, not heat per se, or even temperature. But there's other cases where we're just totally wrong too.
Yes. Well, so there the idea of domain specificity really makes a lot of sense.
Yeah.
So, well, I want to leave us plenty of time to dialogue with the audience, but before we thank you, I want to give you we have a tradition where you've engraved bottle of wine. You can see it's embossed with your book cover.
That's so awesome.
Yeah, so thank you so much for such a great conversation.
Thank you.
So please take a copy of the book, grab a copy of Skeptic, grab some food, have some wine, let's have some fun, party time. There are no alternative facts. You know what you call alternative facts with evidence? Facts. That's it. By the way, you know what you call love without evidence? Stalking. Thank you.